Okay, let's get started right away with the Cytoscape hands-on. So I think Camilla already gave you like a very good introduction on what Cytoscape is, but I think the best if we now actually figure that out a little bit by ourselves. And I would encourage you all to just like open the software. If you have not downloaded and installed it yet, then you can just Google Cytoscape and then hopefully get to the download link and just like download it. As Camilla mentioned, this is like a tool that is like widely used in like the life sciences and also other sciences, including social sciences. And it kind of allows you to like visualize any like connection between things. Right? And in principle, it's a combination of like a spreadsheet program and like this like network visualizer. So you can load in tables, you can generate tables, you can do like matrix operations and like calculate stuff within like the tables, and then like visualize them in the same time. And when you like start the software on your computer, you should basically like see like this window here, and then you can see here I visualized a bunch of stuff before, so there's like some old networks here that I could quickly navigate to, but then also there's like this table section on the bottom where like now when I start putting stuff in there, there will be some data appearing, and then on the left there is like a network overview. And now the most simple use you can use this now for is to basically drag and drop the GraphML file, just like in this white big box here. So that was one of the files we downloaded earlier from like the GMPS output. But before you do that, I would actually encourage you to like build a network yourself to kind of like understand a little bit more about like the structure of how Cytoscape visualizes things, because this will open up completely new ways for you to like actually analyze your data, to integrate, different layers of annotations, like, the outputs of series or canopus, what we're going to do in a couple of minutes, but also maybe use this for something else, right? So Camilla mentioned like gene similarity networks, interaction networks, protein metabolites, so we've been using this for a bunch of stuff, and the community is, and I think it's a wonderful tool to like visualize any information flow or between things. And to get started, so we can just like generate a new network, and you would typically do this here under file and a new network, and then generate like an empty network. We can just call this test, and then here, well, if I create a few, then an empty network should appear. So just like a blank page here. And now if I want to add information into that, there's like different ways. Like the most simple one is that I just like right click into this empty network here and add like a node. And then I can add a second node. And then I can right click on one of the nodes and add an edge and connect these nodes. And now the most simple network possible, I already created like 2 neighboring nodes that are like connected. And I really like to, use this for whatever. So I don't know, for my friends, for connected papers, for, famous television characters. And as we've been talking a lot about, different comic characters recently, we could, then just like give them whatever. And in order to do that, like I can go here on this node table, and then actually just like click in here in that table, right, that now contains this information, and change this here to fry, and then node number 2, I could call vendor, and now the edge could like indicate that fry and vendor are friends, right? And then I could add other nodes, such as, like the professor, who is the boss of Fry and Bender, and I could like indicate this through another edge. Okay? So now, obviously, this is going to be very labor intensive if I want to build my spectral network manually like that, or like any other network. So I need to like somehow import like a network like more easily, right, into that. And there again, it's really important to like understand like the data structure of like the files you're dealing with, because then, you know, it becomes more simple for you to like actually, you know, modify and like debug things, and also like come up with like completely new ways of visualizing your data. And yeah, like, so the most simple thing would be that we have here like an, you know, example table. Here I got some for, again, Fry and Bender and so on. And I call those names, right? And that would be like a simple text file, which I can visualize here quickly for you in Excel or in the editor or whatever. And that's kind of just like a list of basically different like items. So yeah, this actually loads and doesn't let me down. Yeah, then I will, you know, get now here, just like this like little table. So it's numbered 1, 2, 3, 4, and so on. And then the characters are like Fry, Lila, Bender, Professor Farnsworth, and so on. So now, obviously, this does not show any like connectivity, right? So these are just like items. So that's why in order to like build this network, I also need a file that actually tells me what to what is like connected. And this would be then a so-called edge file. And now if you think what files we uploaded earlier to GMPS, there was already this IIN edges file, right? And this is exactly such a file that basically connects different features by their IIN identities. And also later, if you will explore a little bit in the GMPS output, you will find such edge files, right, that build that. And like, yeah, like the same way, you know, I can open this in like Excel or the editor, and I will now just see here like the most simple way, you know, self connections between node number 1 and 1, between 2 and 2, and so on. Now I could also add new connections, like I could say 1 and 10 are connected, and 1 and, I don't know, 5 are connected, and so on. And now obviously I think it was relatively big and generate big networks. And yeah, I would encourage you to actually just, as we're talking now, like to write like such a small file as a test example for you and actually try it out. And then, yeah, I can save this here as like a text file. It can be also CSV format, so it's quite flexible. And then if I go to Cytoscape, I can now go to File, New Network, or import, import network from file. And then select this text file here, edges, and then bring it in. And now there's like this wizard here popping up, which actually asks me, okay, which information should I connect to what? Because these tables can be like fairly large, you know, and have like other metadata in there. So I need to tell it what is actually like the, you know, the name of like those nodes. And in my case, it's fairly simple because I only have two. So one is like the source, and the other one is the target. And I can, yeah, like basically define this here, and then hit OK. And then it would just like load now these nodes in here. Okay, and now, well, it's just like numbers, so I don't really know what like those things are. But now to these nodes, I can now load in the other table, which actually gives me like all like this meta information about like these nodes, right? And such meta information could be like the outputs from series, right? If those were like IIN features, then I can now load in like the series IDs as a layer. I can load in the library IDs as a layer. I can load in MS2LDA, you know, like substructure information from Justin tomorrow. So I can like stagger these networks. And this is really powerful because, you know, it opens up like a data integration to whatever. So if, I don't know, de novo annotation will become a thing, then maybe next year you can load in MS Novelist, you know, and so on. And yeah, just to also like do this really quickly, here's an example. I'm gonna go to import and then import table from file. And then I can now load this names table and open it. And now here, I just need to like set this key symbol here to actually tell it what is like the variable of like these nodes that needs to match this information to. It's a little bit like the V lookup function in Excel, right? So you want to merge two tables on top of each other. So you need to know what the identifier is, or like the merge function in RBase. So, okay, if I set this, then I can like load this in now. And now you will see that in my table view here, I get like the list of like character names as well. And now I can go here to the style and then actually start changing like the labels of the node by like going here to label and select now character as like the attribute and use like the path-through mapping. And then very nicely, I get all like the different like characters, and I could like even, generate new connections. For example, here, Kif is like the close friend and colleague of Seb Brannigan, and I can indicate this here, like in the network. Now, you will also see that there is like the self-looped things, right? So like each node has kind of like a self-loop thing. That is an artifact because I needed that initial network to load it in, right? If I want to get rid of this, there's now different ways to like manipulate this network. So I can like go to, I think it's edit, and then click remove self-loops, and then just select this network and remove like the self-loops, and it looks already more like the actual network. There's a lot of like here singletons. So these are like nodes that are not connected to anything yet, unless I generate this. So yeah, in principle, you can like do this with everything. What I just said, but for like the rest of the course, obviously we want to deal with features for today. So I would suggest that we, after you played around with it for like a little bit, move on and actually start loading in the GMPS output. So now I have not a job here. So I actually need to like download this. And as I mentioned earlier, we had like a little server issue, which I think in the meantime got resolved. So hopefully most of you have gotten an email now from GMPS that your job is finished. So you can download like now the Cytoscape data from there, or you can also go to the summer school folder and actually download these files from there. So I'm just gonna quickly do it because I don't have it on my computer yet. And I'm gonna show you where this is like located. So under the data folder, there should be GMPS. And then in GMPS, there's like the sampling and then also like the particular links. Quick question to the serious people, which one should I use that matches to what you uploaded? It's the example, correct? All right. So for you, if you want to do the exercise, obviously I would then use like the one from like the group you're working on accordingly. Okay. Yeah, good question. I'm gonna show you quickly. Unfortunately, I don't have that link open on my computer, but I can just like show it as an example from like the latest job I run. So there should be a button download Cytoscape data. It's actually pretty straightforward. So this is like the view you get on the feature-based molecular networking output. And then there's download Cytoscape data. And then when you download this, you get like a zipped folder, which you can then extract. And like the very same folder is also here in this GMPS folder on the Google Drive, right? So it's here, this folder. I'm just gonna quickly download this. Hope it won't take too long. Yes. Wow, that was fast. I'm surprised. Okay, so yeah, in this case, it's like 38 megabytes, and yeah, it's still zipped. So I wanna, extract it now. Extract to, and then I get like, all like these different files. And now if we go in, so earlier I showed you the library hits in there, but now with your new knowledge about like this edge tables, maybe some of those files start to make more sense now for you. So if we, for example, look at like the network edge self loop, and if I open this in Excel, I will see exactly such a table that theoretically I could like load manually into Cytoscape. So the GraphML is just like a shortcut because this is basically already like a network that has been generated. Oh, doesn't wanna let me do it. So I'm gonna open it with Notepad++. So yeah, it's basically like a table, and has like exactly like this edge information. And yeah, like in the very early days of GMPS, you had to like build your network manually like this. And I mean, one exercise I would actually recommend you to do it at some point to get like a better feel for the data structure. But yeah, now like the easiest way to get the stuff into Cytoscape is to use like this GraphML file here. Mm-hmm. Yeah, so you can just open it and check them out, but you actually don't need them. So I would suggest to just use the GraphML for now. Is this like a little bit better to see now? But still too small. All right, let's see. Is it okay? All right. So yeah, if you wanna now drag and drop like this GraphML file, you can just like, oh, okay. So yes. So just like that GMPS molecular network GraphML. So there's also the IIN collapsed one. So this has like some reduced complexity by like collapsing the different adducts into one node. But yeah, like this here would be the generic one. So, and then yeah, you drag and drop this into Cytoscape, and then it should load it now. And then you will also see, because I've been like messing around with like this Futurama network here. They will be listed as different networks here in this table. It's also like, yeah, like a way to navigate. If you open different molecular networks, you can have them all in one file. But yeah, what you should see now is basically like that, like this larger network appears. And then yeah, like in the very same way, as I just like did this, like I could zoom in and like investigate individual nodes, and then like see like all like this meta information about these nodes. All right. Yeah.
What's the difference between if I'm downloading the direct Cytoscape preview for download, like it's showing it different. So what's the difference between those two?
I think like just like the direct download shows you like a preview. Yeah. And then the GraphML should be fairly the same, I think.
So it's just here you don't show the pie chart.
Here you can show the pie chart too. You may just like need to like indicate it through like the mapping. So Yeah, for now, I would suggest you use the Cytoscape download. So this one here, as the other one sometimes also is buggy. But yes. All right. So who of you has a network, a molecular network in front of them? Right. Okay. Who is still struggling? Okay, then maybe if it's just a few, some of the other instructors could like pass by and give you a hand with that. Just like raise your hand, please, once again.
What's the difference between the GraphML file and the main folder? And then there's two other GraphML folders.
Mm-hmm. Good question. So there's a question, what's the difference between the GraphML and the main folder? So this is this one here and that one in the subfolder. I think it's just an artifact that this is like additionally created. Let me see if it has the same size. Yeah, it's 50 megabytes and 352 kilobytes, which is very much the same. I think it has something to do with that if you download data from GMPS in general, it always gives you everything. But then if you click on a particular thing, it additionally downloads that file. So yeah, you can ignore it or like choose either of the two. All right. Okay, so then yeah, like when you have like this network, then obviously like one of the first things is that you wanna start like changing like the style, right? And then you go like to the style tab, and then again, like I labeled like Bender and Fry before, you could now change this here to like, I don't know, compound name, you know, and use like path-through labeling to quickly identify like the nodes that were actually annotated with the library. Now, if we zoom in, you will see, oh, there's actually now a bunch of nodes that have like these annotations. And when you zoom a little out, you will also see that the vast majority actually do not have like annotations. So it's just like a small subset of everything. Okay, something like more universal would be, of course, like their molecular weight. So we could change this here, again, under label to like precursor mass, and then label this path-through mapping. And then every node should now have like the mass as a label. So this is now very similar to what you've seen like in this web-based visualization tool earlier. And yeah, it's kind of like a default thing. Okay, we still have like the self-loop nodes here. And then you may wonder, why do we have like some of them being self-looped, but still like connected to others? And that is due to the fact that we have like an ion identity molecular network here. So we not only have MS2-based edges, but also like this like coelution-based edges from like the ion identity molecular network. So first of all, I want to know which ones are which, right? So here I could now simply like change the color of like the edges that are like MS2 to the color of the edges that are like IIN based. Therefore, we can like go here on the style and switch to like the edge tab on the bottom. And now change like the stroke color to the mapper of edge type. And now differentiate with a discrete mapping between cosine and make this, I don't know, blue.
Oh, sorry, you're going too fast.
Yeah, I'm gonna show it. So, okay. So under style here on the left, I switched between node and edge. So those are like the tabs on the bottom, right? So on the node one, I can like basically change the style of like the nodes. And then if I switch here to edge, I can change the style of like the edges. And then there's like the stroke color option, where I can now change the style of like the stroke color. So this is basically the edge color. And then I just need to like find now a category from like my table, you know, which like discriminates like the edges that are based on MS2 versus like the edges that are based on like this IIN annotation. And this here is called edge type. So you can you just like open this and see like the different categories. And then I can use like the edge type and now say cosine if I click in there, I can use like a color as an indicator, and I don't know, like use blue for cosine. So this is MS2. And then for MS1 annotation, I could use red. And then I will see immediately in the network here which edges are based on my MS2 similarity and which one are based on ion identity. And then I will see again, I have like some self-looped nodes. So those are like those nodes that based only on molecular networking did not have like any connectivity in the network. So earlier, those ones were actually at the bottom of the network together with the other like self-loop nodes here. Right. But thanks to the ion identity molecular networking, they're now connected. And then when we look at like the masses, then we will hopefully see that those mass differences correspond to like some of like the masses you allowed yesterday during like the IIM. So that could be like a sodium adduct or like ammonia or like some in-source fragments. Again, I can calculate this now in my head, or I can also be lazy and quickly label like this mass difference here in between the edges. Therefore, again, I would use like a mapping here under style, again, under edges, and then just like select the label to be the mass difference. And then use a path-through mapping again. And then like these masses should now appear on the edge. And then interestingly, we have here a delta of 15.974. So that could correspond to some oxygen. And I don't know exactly what Robin and Steffen allowed to be delta masses, but that could be eventually like some sort of like in-source fragment. And then if I go through, I hope I would see also some that correspond to like sodium, like here, 21.98. So that would be like the two different, sodium adduct versus like a protonated ion. All right. If those self loops still bother me, again, as I did it before, under edit and remove self loops, I can remove those self looped edges, and then like clean this like up a little bit. All right. So now, okay, what else can we do with it? So like first of all, I can like use like different like sizes to like point my attention to like the most abundant features, right? So I could use here like a mapper now under nodes again that indicates my precursor abundance. Like in this networks of these features to like highlight quickly like the most relative abundant molecules. And then, I could like also load in like any other information that might be valuable for me. So like a very classic thing that I'm not going to do here is that we typically build like log ratio between our control and knockout, and then I could like visualize such information in here too. In a second, I want to show you how to integrate this, but before, let's first play around a little bit more with like the mapping options. So I mentioned like I could here change like the size. So this I do basically through the node width. An important thing is here to like lock the node width and height, so they become kind of like more like square shaped. And then I can like use the size now as an indicator. Then I would use like some precursor intensity as a value, and then use like a continuous mapper to actually change like the node size. And you'll see there's like this gradient visualization. And if I double click on that, then like this window should pop up, and I can actually change now the values for like the different precursor intensities. And you see that they might be very small, right? So I just can make this generally like a little bit bigger, and then hit OK when I'm happy with it. And when I zoom out now, I should hopefully see that some nodes are larger than the others. Okay, this is still not very extreme, so I may want to make them even bigger. And then I should hopefully start seeing, oh yeah, there's some like more abundant features, you know, and that is a way like how you may already like highlight some of like the main drivers in your sample.
Can you choose how to scale this, like linearly or on a logarithmic scale?
I don't know if you can do logarithmic, but you can like add different points in here by like, yeah, like add a point and then, you know, adjust this a little bit. I don't think that there's a logarithmic option, but I mean, you can add a couple and make it pseudo logarithmic. Yeah, feel free to play around with it. It's not like the most important thing, right? So like I typically use it as a general information, but like, yeah, like this relative abundance is maybe not like the most important biological information. All right. And like, yeah, like playing with like the size here, the same way we can do it for the nodes, we can also do it for the edges. So what interests me, of course, is like how similar are like these spectra. Hence, like the ones with like the very, you know, like good cosine scores might be more trustworthy than the ones with like the lower cosine scores. So like similarly as for like the nodes, I can like also use like this mapper for like the width of like the edges. So then same way, I would select here the value, such as like cosine score, and then also use like a continuous mapper, and then actually make them, you know, like different in size depending on the cosine value. Now I just have to be careful because like the IIN is now really small, but I can just adjust this by setting the default value. So that is basically everything that is not defined through like this mapper, like a bigger value here. And then I would see that now also the IIN edges are just like 10 in width by default. And then the blue ones, depending on their cosine score, have like a different width. All right. So now I think we get already some more information into this network, but now, of course, like what about like biological relevant information? So particularly like this A-B questions are like classic scenarios. You have like a knockout mutant, or you have like a two cohorts like of I don't know, like your treatment group and your control group, and you want to like now check, okay, are those features like differentially abundant in here? And this is where like the metadata comes in very, very handy. And like you want to like provide this design, this experimental kind of like, yeah, meta information about your samples already into the analysis of GMPS. Because what GMPS does with like that metadata is that it creates like average intensity values for these groups. And those you can then select here as a mapper to like display this information in a pie chart, for example, over the nodes. In order to like generate these pie charts, we would go here back to node and then use like the image/chart option and like include here the pie chart. So again, it's here under image chart. And if it's not appearing, there's this property option here where you can actually hide and bring in some of the settings. So, but I think by default, it should be there. Sorry, can you repeat this? Yeah, so do you see the image chart option? Okay. And then you just like click here on one of the boxes. And then there is in the drop down, there's three options, image, and then chart. And then if you click on chart, there's like different chart types, and then you can like use like the pie chart. And then you can like now load in different groups that actually gonna get displayed. So here by default, it's selected charge. That's obviously not of interest, but I can now go here on my different GMPS groups. And to be completely honest with you, I have like no idea what in the metadata was, but I assume that something like skin and plasma might be meaningful. So I will select those two, but obviously this depends on your metadata. So if you had like two categories like treatment and control, you would select those. Or in my environmental metabolomics data, if I have like 10 different sampling sites, you know, I would like select those. And then I can like visualize like the average intensities in there. And now if we zoom in, you will see that now on your networks appear like this pie charts. And then I can quickly see that some of those nodes have kind of like only one color in the pie chart. So then they may come either from like or are present in the serum or in like the skin. And some others are like present on like both, right? So obviously this is like super simple, but yeah, like you can play around with it and eventually use more categories or different categories. Okay, everybody got to the pie charts? Did this work? Can I see some hands who got pie charts on their network? All right, who's still struggling and needs help? Okay, then I would ask perhaps one of the expert helpers to stop by. I think over there. Yeah. All right. So yeah, I think for like the first part of like visualization, that was pretty much what I wanted to show you. After the break, we're going to continue and then load in like additional information from Sirius and maybe also make up some of our own fantasy data. Are there any questions for now for like the visualization part? Yes.
How do you remove the self-loop nodes?
Yeah. Okay. The question was how we remove the self-loop nodes. So if you go to edit, there is a remove self-loop button. And that is just magically removing it. So it's fairly simple. So yeah, it's pretty intuitive to use Cytoscape, I think. So feel free to also like explore. And yeah, as Camilla mentioned, there's a bunch of like different add-ons or now apps, they call it, to like use different styles. So like one problem that I, for example, I often faced was that like nodes were like overlapping, and then you can like, I think it's the Y-Files app, you can download this and then like remove overlaps, right? Here on the very bottom. This is like super nice, right? If you especially messed up here, the size, you know, then you can use like such tricks to like clean up your network or restructure it. Then on the layouts, you may wonder why Scott's network this morning had like all like this beautiful circles. You know, that's just like a different mapping layout here in Cytoscape. So if you go to layouts, then you can explore different layouts and check them out. So I think it was the circular layout that he may have used, right? And then yeah, it was just like one click. I will now also get some circular networks. All right. Any other question? All right, then let's take the coffee break and then let's continue in 30 minutes.